Hello, dear engineers and technocrats. I welcome you all to like and share your favorite YouTube channel, Industrial Engineering Guru. Today I will start acceptance sampling, which is one of the most important and interesting topic of your quality management subject. After completing today's session, you will be able to define acceptance sampling. You will be able to explain the purpose of acceptance sampling, and it will enable you to define several sampling plans. So in today's session, we will define these sampling plans, and in subsequent sessions we will discuss these plans in more detail. Now, statistical quality control can be broadly categorized in two streams. One is process control and another one is product control. Process control stream is also called online quality control, as control charts are used to measure and monitor the process quality during the production process. Whereas product control field is also known as offline quality control. Here, acceptance sampling approach is used to measure and monitor the quality of product either before or after the process. Acceptance sampling is a process of randomly inspecting a sample which is taken from a lot or a batch, and based upon this sample inspection, the sample is inspected 100% and for all requisite quality characteristics, and based upon this sample we decide whether to accept or reject this entire lot. So in a nutshell, you can say that in acceptance sampling, based upon sample inspection, we decide to reject or accept the entire lot. Acceptance sampling can be used for both variable and attribute measures. However, it is most commonly used for attribute measures. Acceptance sampling is used to monitor the quality of raw material, purchased parts, or finished products before supply, when product testing is destructive, time consuming, and expensive. A sampling plan is an important tool of acceptance sampling. It is a plan for acceptance sampling that precisely specify the parameters of the sampling process and the acceptance and rejection criteria. The important parameters to be specified in a sampling plan are size of the submitted lot, that is denoted by capital N, the size of the sample to be inspected from the lot small n, the number of defects above which a lot is rejected, also called acceptance number C, and the number of samples that will be taken to decide whether to accept or reject the lot. Now, depending on the number of sample based on which a decision is made about the submitted lot, we can have four types of sampling plan: single sampling plan, double sampling plan, multiple sampling plan, and sequential sampling plan. Today we will define these plans and we will discuss these plans in more detail in subsequent sessions. We will design each kind of sampling plans, and we design the sampling plan so that it is effective. Now, what do you mean by effectiveness of a sampling plan? It means we evaluate a sampling plan based on how well it discriminates between a good and a bad lot, and at the same time this sampling study should be carried out in the most economic way. So all these plans are to be evaluated based on discrimination power and cost criteria, and best plan is chosen between the supplier of the lot and consumer. Now, single sampling plan, as the name indicate, the decision regarding rejection or acceptance of the lot is made on the basis of a single sample. So here a supplier submits a lot of size n, then the customer takes a sample of size small n. All the items of the sample should be representative of the lot. It means they are randomly selected from the submitted lot. Now these items of the sample are thoroughly inspected for all the requisite quality characteristics, and number of defectives are counted. Now if number of defectives found are less than and equal to the acceptance number C, then the entire lot is accepted by the customer. If the number of defectives found in sample is more than acceptance number, then entire lot is rejected. So The single sampling plan has three parameters: lot size capital N, sample size small n, and acceptance number C. Now this lot is accepted based upon inspection of sample. If defectives found in sample are less than and equal to acceptance number C, then lot is accepted. And so we can determine the probability of accepting the lot, that is known as PA, equal to, we determine the probability of having defectives at most equal to acceptance number C. Means a lot is accepted if we found 0 defectives, 1 defectives, 2 defectives, or less than and equal to C defectives. Now all these probabilities can be found by using hypergeometric distribution. We can also use binomial distribution or Poisson distribution, particularly when the submitted lot is of infinite size or we have a continuous production of items. Or we can say when the lot size is very high or very large, then sample size n, then we can use binomial distribution and Poisson distribution. When you will solve the problem, you will find that calculation performed by using binomial distribution and Poisson distribution are much simpler and faster than we get from hypergeometric distribution. So this is the reason why we should go for binomial and Poisson distribution instead of hypergeometric distribution. But these conditions must be fulfilled if we use these binomial and Poisson distribution over hypergeometric distribution. Now probability of rejecting the lot is 1 minus probability of acceptance, or we can say when number of defectives found in the sample is more than acceptance number, then the entire lot is rejected. So using this distribution, any of the suitable distribution, we can find out the probability of acceptance or probability of rejections for the given fraction defectives and the by defining these three parameters. So single sampling plan design consists of these three parameters, and based upon these three parameters and fraction defectives, we can determine the probability of acceptance and probability of rejection. We will discuss this more in detail when we will design this plan in subsequent sessions. In a double sampling plan, the decision regarding rejection or acceptance of the lot is made on the basis of maximum, please underline, maximum 2 samples drawn randomly from the lot. So it is not necessary that you take 2 samples always. You can take 1 sample, and if need arises, you can take 2 samples. So decision is based on maximum 2 samples. So here a lot of size n is submitted, from which we take a random sample of size n1. We inspect it thoroughly and count the number of defectives. Now, if the defectives found in sample 1 is less than and equal to C1, acceptance number C1, the lot is accepted. If the defectives found in first sample is more than second acceptance number C2, the entire lot is rejected. And if the defectives found in first sample are more than first acceptance number C1 but less than and equal to second acceptance number C2, then we take the second sample of size N2. Thus, a lot may be accepted if the sample is good enough, or may be rejected if it is bad enough. And if the first sample is neither good enough nor bad enough, that is, the result of the first sample are inconclusive, then a second sample of size N2 is drawn randomly from the lot, and the acceptance or rejection decision is based on the evidence of first and second sample combined. So what we do, we count the number of defectives after thoroughly inspecting second sample, and based upon these combined defectives we take the decision to accept or reject the lot. If the combined defectives in both the samples are less than and equal to second acceptance number C2, we accept the lot. Otherwise, we reject it. Double sampling plan is defined by 5 parameters. As we discussed in previous slides, it is lot size n, size of the first sample n1, first acceptance number C1, size of the second sample n2, and second acceptance number C2. Now, size of the first sample n1 and size of the second sample n2 may or may not be same. Usually, in double sampling plan, when the number of items to be inspected may also be less than the sample size of the single sampling plan. This may be a situation which we will take up in subsequent sessions. Now in double sampling plan, 4 different possibilities arises. That first is that sample may be selected after or lot may be selected after inspection of first sample, or the lot may be rejected after first sample. If defectives in the first sample is less than and equal to acceptance number C1, we accept the entire lot. If defectives found in first sample is more than second acceptance number C2, the entire lot is rejected. So this is the probability that a good lot is good enough lot is accepted, and this is the probability that a bad enough lot is rejected. So PA1 is the probability of accepting the lot after first sample, and this PR1 denotes the probability of rejecting the lot after first sample. If lot is neither selected nor rejected after first sample, then based upon combined defectives, we decide to accept or reject a lot. If the combined defectives are less than and equal to second acceptance number C2, we accept the lot, and this is known as probability of accepting the lot after second sample. And if the combined defectives are more than second acceptance number C2, the entire lot is rejected, and this is denoted by PR2, that is probability of rejecting the lot after second sample. Now in second sample, these four possibilities are mutually exclusive, so the sum of all these four probabilities would be equal to 1. In double sampling plan, the necessity of taking second sample arises when we are inconclusive after first sample. That is, the number of defectives found in first sample are greater than first acceptance number C1 but less than and equal to second acceptance number C2. So in such a situation, we need to take second sample, and probability of this situation gives us the probability of continuation of sampling. That is, after taking first sample, what is the condition or what is the possibility that we have to take second sample. So in order to determine this probability of continuation of sampling, we should find out probability of all such events. This can also be written as 1 minus probability of accepting the lot after first sample or probability of rejecting the entire lot after first sample. So 1 minus sum of these two probabilities gives us the probability of continuation of sampling, and you know that there are four possibilities: PA1, PA2, PR1 and PR2, and all these are mutually exclusive events, and sum of all these events would be equal to 1. So 1 minus these two probabilities gives us probability of accepting the lot after second sample plus probability of rejecting the lot after second sample. So the total when we take the sum of probability of accepting the lot after first sample and probability of accepting the lot after second sample, the sum of these two probabilities gives us the probability of accepting the lot in double sampling plan. Multiple sampling plan is very much similar to double sampling plan, except that acceptance and rejection criteria are set for more than two samples. If the cumulative number of defectives at any sample equals to or less than acceptance number, the lot is accepted at that sample. So just we discussed in double sampling plan that combined defectives are less than and equal to acceptance number, we select the entire lot, and if the cumulative number of defectives at any sample equals to rejection number, the entire lot is rejected at that sample. Later we will design this multiple sampling plan and solve a numerical problem. You will get more clear-cut ideas how we can design such plans under the given situations. A sequential sampling plan is the ultimate extension of multiple sampling plan, where items are selected from a lot one at a time, and after inspection of each item, a decision is made to accept or reject the lot or select another unit, or we can say continue sampling. Sequential sampling plan is used when inspection is costly or require destructive testing. We will also discuss the sequential sampling plan in more detail in subsequent session. If you find today's session useful and interesting, please hit the like button, share it with your friends, and subscribe it if you have not subscribed it yet. Thank you all for patience hearing.